Thank you and hello everybody. Thanks for coming. What I will be presenting is an open source piece of software. So ideally, it could be in a branch state of the software. We have decided to put it into open source made in Europe instead. I think it could fit into both just fine. Just a bit of agenda, and I'm putting it mainly because I want you to scan the QR code, which is hosting a live demo of the whole view server, and because we are on a not so data heavy environment, I'm not going to be doing any live demo, so you can exhaust the network yourselves. But I will mainly be talking about the project itself, what it can do as a piece of software, and how you could use it, but also how you could contribute to it. Why something like view server even exists is because we are, as EOx as a company, providing services for viewing, cataloging, downloading, and also sometimes processing Earth observation data. And we needed a software for it that we are happy to work with. It is a long evolution. So it started as a software called EOxServer, which is a Python Django application, and it has been around for many years. This is an evolution that is going into cloud native way, mainly because we have switched to microservices architecture and built things around EOxServer, which is still in its core. As I already said, it has an open source license, it's MIT. You could clone the repository and work with it for any purpose that you want. What we provide is continuous development of new features, maintenance and updates, but also configurations for our clients. And we do it under the scope of providing the services. This is architecture diagram of view server, where you see that the EOxServer as its core in all the red boxes underneath. So there is always some kind of database for storing the metadata information about the Earth observation products. So we have some kind of data model that we pass all the products to. And we have two components, the render and the registrar, which are part of this whole EOxServer core, where the render is providing the external services, the WMS and the WCS and OpenSearch, while the registrar is mainly dealing with registering data into the system and mapping the storage and the product information with the database models. So you configure where you will register your data to, into which collection, for example. So a little bit more about the EOxServer, which is the core. So it's a Django application. It has its own GitHub repository, and it is using MapServer, another open source long-lasting tool for all the rendering and providing the services, so the WMS, WCS. There are also a few other external endpoints. We have a WPS interface for in both versions 1 and 2 for processing. And we also have something called DSEO, for example, which is a download service for Earth observation. And EOxServer as itself is a reference implementation of WCS and also WMS EO. We are working on including Stack API for search. Currently, it's not there yet. That's why it's outside of the orange box here. Rendering. So we are quite proud of how flexible and how configurable the WMS rendering is. Any type of observation data that you can think of, it probably has been used with view server. So in terms of WMS access, we have band selection using the custom dim bands key. We have a range stretch, so that means that you can really stretch the original raster values into your RGB scale and play with this. And any WMS client using these custom parameters will do the same. We also have rendering variables. So if you have some flexible configurable rendering, like for example hillshade, you can as a user pass in the parameters of the hillshade rendering into the server rendering process itself. There are other types of rendering, for example, which you can find in QGIS, which is the percentile-based rendering, which means you have already pre-computed statistics in advance before you register the data, and then you use these to apply the stretch on a per product level. So each product can have a really different color scale. It can be brighter or darker. Well, this is where the cloud, this type of rendering is really helpful. We also support some kind of basic band algebra in terms of, for example, on-the-fly NDVI rendering. We can do pansharpening on the fly, which means when you have a panchromatic band registered alongside all your multispectral bands with lower resolution, the pansharpening operation on the fly will make a higher resolution rendering image. I've already talked about hillshade. We also allow masking, which means you register the vector mask in parallel to the data, and it will be used to mask out invalid areas in your final WMS rendering. Of course, CQL operations on the products are also allowed. So for example, this allows you to filter out only products with less cloud coverage than, I don't know, 30%, if you have the metadata information about the cloud coverage of the product. You can pre-configure browse types so you can pre-configure some kind of renderings which will be used by a cache service, so that you have a subset of the layers used also for the cache service, which I will be talking about a bit later. The layers parameter as part of the WMS is flexible in a way that it can also reference some kind of layers, so basically a mapping to some kind of collection, but also we can do a per product rendering, which means you just get one image for one product, and this allows you to be quite flexible about what you request and what you provide to the users. Here are some examples what this means. On the left side, you see the false color rendering with some custom stretch and band selection. The middle one is using the CQL filtering on the cloud coverage, so only products with less than, I don't know, 5% cloud coverage are selected. And the last one is really masking out the parts of the rendering based on the vector mask that was registered along. Here another example of the pansharpening being done on the fly. So on the left side you see the lower resolution true color image just using the multispectral bands, while on the right also the panchromatic one is being requested, the pansharpening is done on the fly, and this is the final result. The next is the cache service, which is having two different endpoints, the WMTS and WMS, and it's always or almost always deployed together with the view server, and it's a caching mechanism using the MapCache service, MapCache software. Again, open source software, where the connection between them is that we pre-configure the MapCache configuration to be, for example, a subset of all the layers with predefined zooms into which you use the cache service. And we also have a seeder service, which allows you to, whenever you ingest a new product, it automatically triggers the seeding operation for a predefined set of zoom levels, so that you have seeded layers already shortly after your new product arrives to the catalog that you reference to. On the diagram, you see how the operation of fetching a tile works, but it's a standard MapCache behavior where you simply have a request for a tile. If the tile is existing, it's instantly fetched. If it was not created yet, the request gets proxied to the renderer service and then rendered, stored, and returned by the MapCache service. On the image, you see the WMTS tiles for 3 different renderings, the NDVI, false color, true color from the same data, just using different bands. The false color is the near infrared, red, and green. As part of the whole view server, there is also a complete web client, which is configured to reference all the collections that are there in the view server currently at the time when you deploy it. It also allows, it is simply a very configurable piece of software that we also used for other projects, not only for the view server itself. It allows quite flexible viewing, filtering, and download. So put to basket and then trigger some download request. For the download, we of course use the WCS interface or some other protocol if the client is, if you, for example, want to use the direct S3 download, this is also completely configurable. It is also holding a little bit of a state of the last visit of the client so that you can really share the URL with your colleague, and some parameters of the client get automatically parsed from the URL, and this presets the client in a certain way. It's map position, time selection, and filters. These are basically the things that are usually necessary when you want to share the state of the app. But the app itself is stateless in a way that it doesn't have any user management, authentication, and so on. This is simply a client of all the interfaces that the renderer provides. This is another part of the client, which is the per product page that you can access mainly by clicking on individual products, which can have, again, different layers configured, and this is mainly for metadata listing. So all the metadata, or a subset of them that you have registered, will get then displayed as a response from the OpenSearch interface, which we internally use currently for basically the search and filtering capabilities. It also can serve as a WPS client so that you can pre-configure which requests are you requesting from the server. We use it mainly for DEM processing in the cases where we host some DEM collection. Here on the example, there is the height, so the draw a line to get a height profile type of process, which is and we also configured several GDAL, hill shade and slope shade and so on processes together with it. The whole per product page is fully customizable in a way that you can basically reference any, for example, iframe with another client rendering application that is getting some information about the products. So we have made a DEM client-side rendering example where simply the cloud-optimized geotiffs are directly accessed and the client and rendered on the client side, which is then of course much more performant because we don't send requests to the WMS services for each change of the visualization parameter that the user might do, and this is a configurable feature. And this uses underneath, in our case, the geotiff.js library for parsing the cloud-optimized geotiffs, but it could be basically any iframe application getting some information about the products. Well, how do we get the data into the system? There are multiple components for that. You can deploy them or leave them out. The main ingestion point into the system is the registrar, which accepts stack items. So that's our ingestion mechanism. You usually need to map the stack items with the information about the products with some kind of storage information so that the server knows where to look for the files, how to store the references to them. So if it's on this or that S3 storage, for example. But how you prepare the data beforehand, either you already, for example, have cloud-optimized geotiffs, then the rendering will be super performant and you are done. Or we have a service called preprocessor, which is then processing the data in a configurable manner on a tile-based in a tile-based way using another library called MapCache, which has many possible usages what you can do with it. We use it mainly, for example, to stack bands or basically convert it to cloud-optimized format. Again, using the FSPec library, we are completely storage agnostic, which means whatever plugin is there for FSPec the ingester will use. As for where to get the data into the preprocessor queue, it's usually either you pull from some catalog or you get some push mechanism. We also have basically these two ways. The ingester is having a HTTP endpoint that you can push your item definitions to, or it has a file system watcher which will simply trigger itself automatically whenever a new product appears. So, or whenever some reference about the product appears. Harvester has multiple endpoints that multiple endpoint definitions that it understands. We have used it for OpenSearch, Stack API, OAuth, and for example, SSH access to a file system to get, again, products to get into the system. Internally, we use Redis queues for transferring the stack items between the parts of the system, which means we are quite flexible in a way how we scale the services, because simply we can scale multiple times each service, and if one part of the whole queue is slower, we will anyway be able to pick up the items later on. So a little bit more about deployment and generally capabilities of the whole software. We internally use it mainly in Kubernetes environments. So we have a set of Helm charts, or currently one Helm chart, which is encompassing all the services. We have a set of default values, and we are then defining our collections and our deployments with new sets of values. And for a continuous deployment, we usually use Flux for simply updating the running instances based on Git changes in Git, where we push the values. We also have a backup for Docker Swarm for older, let's say, systems where having managed Kubernetes was not an option, but we are trying to mainly move to Kubernetes only, and this is from us more supported at the moment. I have a little bit more about the web client, maybe that it can be used to reference other endpoints as well, and at the same time, all the services from View Server can of course be referenced by other clients like QGIS and others. We are also working on the validation schema so that whenever you try to create a configuration, you will already be stopped at the point where you do the Helm create. So that means whenever you try to render all the Helm templates, in order for you not to run into an invalid state already at the deployment stage. So this will be a preset of checks that will help with the operators with setting things up. There are two deployments that I wanted to talk about. One is a tool called EOWidget Client that we use in many agricultural applications, where we use it for WMS exclusively. And you can see it on the image chips in the bottom, where the database is queried for the list of available times, and for each of them, the WMS request is sent for a certain parcel, agricultural parcel on the map. The second example is a Earth observation exploitation platform, common architecture, where all parts of the View Server system are used, and it's kind of the reference usage where WMS, WMTS, WCS, and so on is used, and it's simply a central part of the data access system. There is also a concept of per user workspaces, so that you don't have just one central catalog of Earth observation products, but each user in the platform can deploy their own and will have their own View Server with their own products that only them can access. But then all the whole setup of the View Server is done from the current database state. So the client references only the data that the user has, and this we cannot of course ask the user to configure the whole layers and so on. So this is done automatically with some kind of defaults for the client himself, so for the user. There are a few planned features that we will be working on or are already working on. Already talked about the Stack API, so there will be another search and filtering endpoint. We want to have a synchronization between the configuration and the database models as an optional feature, so that the whole create new layer, create new collection is smoother, and the validation schema as well. you can maybe you can use EOxServer. We would be delighted if you did. It's just the matter of configuration. Please check out our user guide and operator guide. User guide mainly for the interfaces and the sample requests and how to structure it. The operator guide for how to set up the system, how to configure it, how to run it, how to operate it afterwards. And one more slide means you can also contribute to EOxServer. Sorry, a little bit of a delay. It's an open source software, MIT license. We are open to any sort of contribution. Or you can also contribute to the EOxServer itself, which is on GitHub. Again, MIT license and open to all sorts of pull requests. As for the EOxServer itself, it's on our company GitLab, so it is not possible for you to create a merge request because you would need an account. If you want to contribute, please let us know via email. We will set up an account for you, and we will happily accept any pull requests. Also, please let us know if you have any use case which could use EOxServer, and we will try to make it happen. Or if there are any missing features that could be there requested and we simply didn't think about them yet. Thank you for your attention.